Welcome to this section. And here we'll be diving straight into the Python solution of a project. And before we do that, let me reiterate what cohort analysis is all about and the type of cohort analysis we intend to perform on this project. And like I said earlier, cohort analysis is simply about dividing customers into different segments and analyzing the behavior of those customers. Now, in this case, we'll be carrying out a time-based cohort analysis, meaning we want to be able to segment customers into different cohorts, with each cohort signifying the particular month that customer was acquired. To do that, we have to assume that the month the customer made his or her first purchase is the month the user was acquired. Now, from our data, we can extract the months they made their first purchase and classify them, classify those customers into a particular cohort. Now, to give you a good visual illustration of what we're trying to achieve here, on this chart, which is the cohort pivot table, on the y-axis here, you'll find the months, and each month here represents the cohorts. Now, assuming a customer falls into the January 2011 cohort, it means that that customer made his or her first purchase January 2011. And as you can see here, one which signifies the first month of January 2011, that was 100% of customers acquired that month made a purchase on our e-commerce platform. And a month after that, which is the second month, only 24% from this 100% made purchase the second month. And on the third month, which is 2 months after acquisition, only 28% from the 100% of them made purchase on the e-commerce platform. Now, looking at this, you understand that we already have a visual representation of how the retention has been fluctuating for each cohort over time. Now, with these, we can understand what cohort is doing better, which cohort is underperforming, and then we can compare, okay, what makes the cohort different from this cohort? What conditions and offers were given to this cohort that are not available here that is making this one to outperform the other one? So there's a lot actually that we can achieve by using cohort analysis. We can understand the customer behavior, what marketing strategy is working, what isn't working, what offer is improving our customer retention, and all that. So good. To achieve this table, first, we have to create the cohorts based on the dates they acquired. Like I said earlier, we have to group them based on the day they made their first purchase and create the cohorts in that line, and then calculate the percentage of which cohorts that continue to engage with our product on the platform, and then analyze the retention rates and come up with recommendations for the company. Great. So let's move on to our Python code. Now, as you already know, we would require some libraries, and on this line, I'll have to import all the necessary libraries. So I'll import pandas, speedy. A lot of the thing here we'll be doing on this project is all about pandas, data frame manipulation, and all that. So I import numpy as np. And then for visualization, I'll have to import seaborn as SNS and import matplotlib.pyplots as plt. Now for our datetime manipulation, I'll have to import the datetime library as dt and then run. Great. So we've successfully imported our libraries, and the first thing we need to do is load our data into the data frame. Now I have the data on here in the same repository as the code I'm currently running. All I need to do is copy the name of the data, copy, and I have it saved in CSV format. So one thing you need to do is take note of the paths the data is saved in, and I use the .pd or read CSV function to load the data sets. Now, since the data is on the same repository as our code, there's no need for me to write the paths of the data. So if your data is in a different repository, you have to write the path / the name of the data.csv. Now let's visualize our data frame on just the first 5 rows of our data frame. And as you can see, the invoice number is here, the invoice date, the customer ID, stock code, description, quantity, unit price, and then the country. Awesome. So we can move further to carry out a descriptive statistics on our data, just to have a good overview of what our data is like. We can use the .describe function method, and this .describe method only picks out those columns with numerical data types. So if you want to include all the rows, you can use the include equals all arguments to include every feature, both the numerical and the categorical feature. Now, if you notice here, the count for the customer ID is way lesser than every other row. That's to show that we have missing values in our customer ID. So, and we can check for missing values. Check for missing values. Data dot is null. Method dot. This returns a Boolean expression, and we can use the dot sum to sum up all the missing values for each feature. And looking over here, you can see that we have actually quite a number of missing values, or missing data rather, in the customer ID column. And there's about 135,000 missing values. And since the customer ID is missing, there's actually no way we can impute these missing values, because we want to analyze the behavior of customers we know. Customer ID missing could be as a result of wrong entry or maybe even false data. So in order to avoid trouble, we can drop our missing values. Data dot drop and the in place true arguments to make sure we are not creating a new data frame, but instead we're just editing the previous data frame. Can include the in place equals true argument. Good. And let's check if our missing values has been successfully dropped. Awesome. So as you can see, we successfully dropped our missing values. So there's actually no need for this repetitive code. Now we can move further to check for more information on our data frame. Data frame with data.info function. Now, this returns all the features we have on our data frame and their data types. As you can see, the customer ID is in float 64 format. Quantity is in an integer. Unit price is also a numerical data type. And to be able to manipulate the invoice date. Now, this invoice date is generated every time a particular purchase is made. An invoice number is generated, and the invoice date signifies the particular day that purchase was made. So, and you know already from our previous discussion that we want to create the cohorts based on the dates they made their first purchase. So we're going to be doing a lot of manipulation on that particular feature. And to make sure that it's in the right format, it's in the right object type, we have to convert our invoice dates to datetime format. Okay. Hold on a bit. All right. Let's copy invoice dates here. ed dot to date time, open bracket, data, and specify the particular column we're trying to work on. And this will convert the date time, the invoice dates, to the datetime format. Awesome. So see you in the next section where we'll go deeper into our data and carry out some exploratory data analysis to gain useful insights that will be necessary for this project. See you there.